Today we're going to be talking about classifying matter into elements, compounds, and mixtures. So these things are three different things that we're going to talk about a lot this year. So to start with, we're going to talk about pure substances. So matter, like we've been talking about in class, has definite or defined chemical and physical properties. And then it can be divided into different things: elements, atoms, molecules, and compounds. We're going to talk about compounds and elements a lot this year, and those are the ones that we're going to focus on right now. So an element, to begin with, it's the simplest form of matter. So it's a pure substance, which means that it's not made of different things. It's just made of one thing, and it can't be separated into simpler substances by physical or chemical means. What this really means is that it can't be pulled apart or broken apart in any way. Everything on the periodic table is an element, so everything over here is an element. Some examples are Na, which is right here, Cl, and F, which are right here. So fluorine, chlorine, and sodium are all elements, and we're going to be learning more about these this year. But anything on here is an element, and they're the simplest form of matter. Compounds are also pure substances, but they're composed of two or more different elements joined by chemical bonds. So, for example, we have H2O over here, which is water. So we have hydrogen and oxygen bonded together, which we'll talk more about, to create a compound. Then we have NaCl, which is table salt or sodium chloride. So this is sodium and chloride from the periodic table, and they're bonded together or stuck together. Then we have carbon dioxide down here, or CO2, where we have carbon and oxygen bonded together. So if we look over here, compounds are made of elements in a specific ratio that's always the same. What we mean by that is that over here there are always two H's and always one O. That's defined or specific. It's never going to change for water. Then it has a chemical formula. These three things right here, these are chemical formulas. These cannot be broken down by physical means, so I can't just break them apart with my hands. They can only be broken down chemically, and that's true of all compounds. So they're more complex than elements, but they're made of elements. So they're kind of like taking two elements and just sticking them together. Mixtures, however, are combinations of two or more pure substances that are not combined chemically. So they're not stuck together chemically. They're kind of just like mixed together, which is why they're called a mixture. So there's no chemical change that's taking place when mixtures are formed. And each item keeps its original properties in the mixture. So for example, if I have salt water, you can taste the water piece and you can taste the salt. You can taste the two different pieces there. And then they can be separated physically. So down here I have examples of separating them physically. So for example, if I had a block of something, I could crush it and make it into dust. I could melt it, and then I could make separate pieces. So basically I can just separate them without having to do it chemically. So mixtures can include a couple different things. They can be two or more compounds together. They could be two or more elements together, or they could be a mixture of elements and compounds. So one example is air. So the air that we breathe in, a lot of people think it's just oxygen, but it's actually N2O2 and argon. So it's nitrogen, oxygen, and argon. This is a mixture. So each one of these elements has properties, and they're the same properties they would have even if it was alone. This is another one. This is salt water that I was talking about before. So water and salt mixed together. These are both compounds, and they mix together to make a mixture. There's different types of mixtures. So there's two different types of mixtures, and people can get confused with these as well. So homogeneous mixtures. So homo means the same. So these mixtures are ones that are the same throughout. So they look the same throughout the entire mixture. So this could be like milk. So in milk, there's not chunks in the milk. It looks all the same, but it's different things mixed together. Salt water, again, you can't usually tell one part of salt water versus another. It looks all the same. And then something like vanilla ice cream. So vanilla ice cream doesn't have any pieces in it. It's It's the vanilla, it's the milk, it's the ice, it's the cream all mixed together, but you can't really tell the difference between those pieces. So, like, again, this is a homogeneous mixture. It doesn't look different in different spots. So up here, it looks the same as down here. Same thing with the salt water here in the ocean. Heterogeneous mixtures, however, hetero means different. So heterogeneous mixtures are not the same throughout. So examples of this would be like chicken noodle soup. So if you think of chicken noodle soup, you think of the noodles, the carrots, the soup, the chicken. Those are all different pieces of the mixture, and you can actually see them. Same thing with chocolate chip cookies. So you have the dough, and then you have the chocolate chips, and those are different pieces of the mixture. And then lastly is Rocky Road ice cream. So we think of the ice cream, the marshmallows, the nuts, everything. So again, this is the chicken noodle soup. So you can see this is a mixture. It's all mixed together. I could separate them if I wanted to. I could put the celery over there and the carrots over there and the noodles over there, but it's still a mixture together. You can see the different pieces. And then also there's Rocky Road ice cream. So we see the different pieces in the ice cream that we could separate out. So usually people get confused between mixtures and compounds. So mixtures, it says up here that they're variable composition, which means that they can be different. They can have different amounts of each substance in the mixture. So we can have more chicken than carrots, for example, in the chicken noodle soup. And they're not chemically joined together. I can actually separate them out. But over here, compounds are in a defined composition. So we always have to have the same amount of each thing or a defined amount of each thing. And then they're chemically joined. So this flowchart might help you too if you're still struggling. So matter can be separated into two pieces, mixtures and substances. So these are completely opposites. So mixtures can be separated into substances if we want them to be. If you follow this way, we have mixtures, we have two types, we have heterogeneous and homogeneous. So it can't be both of these, it has to be one or the other if it's a mixture. And then if we follow the flowchart down this way, we get pure substances, and they can either be compounds or elements. So elements are the simplest kind, and that's going to be all the things we see on the periodic table. But if we join two or more elements together, we have a compound, which also can be broken back down into elements. So elements are the simplest form of matter. They can't be broken down. Compounds and mixtures can be separated, either physically, like over here, or chemically. Thanks for watching. If you have any more questions, please see Ms. Stott, Mr. Christian, or Mr. T.